Hi and welcome to this video about the Weinzierl KNX Modbus RTU Gateway 886.1 Secure. In this video we take a look at how we can set up the gateway in order to get the data from our Modbus RTU devices into our KNX system. But before we jump into the EDS and parameterize the device, let us first of all take a look at the basics of Modbus itself. Modbus itself is used for a long time now and nowadays commonly used, for example, in electric vehicle chargers, in photovoltaic inverters or also in AC units. And with the Weinzierl gateway you can get the informations of those Modbus RTU devices into your KNX system. But what's Modbus RTU now? Well, basically there are two ways on how you can use Modbus. First of all, there is Modbus TCP that uses TCP/IP as a transportation. And then there is Modbus RTU that uses an RS485 connection. Now here in this video I will stick to the Modbus RTU gateway, but Weinzierl also offers a Modbus TCP gateway if you have Modbus TCP devices. Let us now take a look at Modbus itself, and there I want to start with the data points, and therefore I have a little example here. A push button sensor that is now not connected to KNX, but instead this should be a Modbus push button sensor. And now here you can see we have a list with all the individual data points the push button sensor offers us. So for example, we have a data point for the button on the left side, on the right side, then for the LED also on the left, on the right side, and then for example the push button sensor also has binary input. Now here in this list you can already see two important things. First of all, the register ID of the data point, so basically the address of the data point. And in the last column you can see the data type. And in Modbus we only have 4 data types, as you can see here. And the difference between those is first of all the size. So you can see we have 2 data types with a length of 1 bit and 2 data types with a length of 16 bit. And then we have the access rights to it. And this is also a difference, so you can see the discrete input has a length of 1 bit and only allows read access. While on the other hand, the coil, also with a length of 1 bit, has read and write access. So if we think about it, well, discrete inputs are basically digital or binary inputs and coils are digital or binary outputs. And then on the other hand, we have the input and holding registers, both with a length of 16 bit, so 2 byte. And while the input register only allows read access, the holding register also allows write access. So here in this case, the input register is used for analog inputs and the holding register for analog outputs. And now we need these so-called function codes. But what are those? Well, with the function codes, we tell the Modbus device what we want to do with the specific data point. So whether we want to read it, we want to write it, etc. So here you can see a list of the most used function codes, and in general you don't really have to consider that too much because a lot of work is already done by the gateway itself when you parameterize it. We will see this later. But in order so that you know what the function code is, I wanted to show it to you at this point. So what you can see here is the function code 1 is for reading one or multiple coils. Then we have the function code 2 for reading one or multiple discrete inputs, etc. And down below you can see with function code 5, 6 and 15 and 16 we have function codes for writing values. The only difference being that with function code 5 and 6 we can only change one data point at a time, and function code 15 and 16 allows us to change multiple data points at the same time. But again, you don't really have to consider that too much because a lot of work is already done by the Modbus RTU gateway itself within the parameterization, which we will see soon. So as you can see, the manual is really important for each Modbus device because within the manual, the manufacturer will describe which data points are available, which register ID do they have, and which data type is used. And additionally to that, the manufacturer will also tell you which function codes are supported. This is mainly important due to the writing function codes, so function code 5 and 6, because some devices don't allow the use of function code 15 and 16, where you change multiple values at the same time. But again, this is being described in the manual of your Modbus RTU device, so it's really important that you have this by your hand. Besides that, in the manual you will also get informations on some special cases What I mean with that is, for example, floating point values. For floating point values, you normally use 4 bytes. Now in Modbus we only have 2 byte data points. So what is being done in this case is that this floating point value is being split up in half. So the first 2 bytes go into one register and the second 2 bytes go into the another register. And you later on then need to combine it when you read them out. Again, also this work is being done by the Modbus RTU Gateway itself. You only have to set it up, and therefore you need to know how you have to set it up, and this is being described in the manual. So as I mentioned, Modbus is available as Modbus TCP and Modbus RTU. And while on Modbus TCP we have the IP address to address the devices, in Modbus RTU we have the so-called unit ID. The unit ID is set up within the Modbus device, and this is basically the address that we need in order to send messages to the device. So what in the TCP IP world is the IP address is in the Modbus RTU or RS485 world the unit ID. So now let us connect the Modbus RTU Gateway into our KNX system. Therefore I have it already connected to the KNX line and also connected it to my Modbus RTU devices. In my case here I will use 2 energy meters. The terminals for the Modbus RS485 line are internally bridged, so that means that you can use one terminal for the Modbus RS485 line and the other terminal you could use, for example, for a terminating resistor. So now let's jump into the EDS. So the first thing I want to do is to add the device into my project. Therefore I quickly copy it into my twisted pair line. Now as the name suggests, the device also supports KNX Secure, and therefore I'll quickly enter here the secure key. And with that I can click here on OK. So with that we have the gateway in the EDS, and therefore let us take a look at the parameters. The first thing that I quickly want to do is I want to download the physical address, because we need this initial download to use the scripts, which you will later see. So I click here on download, and now the good thing is that because I used the KNX Secure certificate, I can program it via the serial number. So now with the physical address downloaded, let us take a look at the parameterization itself. So first of all, we have here a little description with some informations. Then in the general settings we can give the device a name and set up, for example, the buttons on the front of the device. So for example, we can disable the programming mode, and down below here we can also press the same buttons that are on the device itself. So here we have the Sync KNX button and the Sync Modbus button that you can also see on the device front. And down below here you can see also the description. So here with the context help you get some additional informations. Now here I don't change anything, but instead I directly hop into the Modbus settings. So first of all, what we can set up here is whether we want to use the device as a Modbus master or as a Modbus slave. So that means we can use the gateway also to provide KNX data points in Modbus to an additional Modbus master, so that the device acts as a Modbus slave. Now in my case, as I want to read values from Modbus and give it into the KNX system, I have to configure it as Modbus master. And then down below here we have the first settings where you should take a look into the manual of your device. So first of all, we set up the slave address of the device that we want to read out. Don't worry, if you have more devices, like I have here in this case, we can later on use also the additional unit IDs. So this is the unit ID of the device that you want to read out. Then we have the baud rate, the parity, byte order and the register address, whether it is 0 based or 1 based. Now these are all settings that you need to compare against the manual of the Modbus slave that you want to read out. Here in my case, all those settings are correct, and therefore I don't need to change anything. Here down below we can set up some settings regarding the Modbus requests, so how often should they be sent. And down below here you can already see what we talked about when we took a look into the function codes. First of all, we can enable or disable if we want to read multiple registers at the same time. Now normally this is fully okay if you leave it to enable, but again, compare it to the manual of your Modbus slave. And down below here we have the function code that should be used for writing values. Now here in my case, I'll also leave it here to default as I only have registers that I want to read out. Next up we have the diagnostic object. That is simply a 1-bit object, a 1-bit group object, where you get the information whether a communication to the slave is established or not. And down below here we have a pretty handy feature, the Modbus test environment. If I enable this test environment, you can see that now here within Modbus settings I have an additional entry, the Modbus test environment. And what this allows me to do is that I can send Modbus requests without the need to download everything onto the gateway. So directly from within the ETS, from this panel here, I can send Modbus RTU requests and can see whether I get the correct value, etc. So with that, you have an easy way to check your Modbus settings. And this is what I want to do now. And therefore I have to take a look at the manual of my energy meter. So as you can see here, we have all the different data points that are available. Now here in this case, I first of all want to get the value of the voltage between phase 1 and neutral. So you can see that here we have the address 2500 to 2501. And that's the case because this is, as I mentioned in the beginning, a floating point value. So this value uses 2 registers at the same time to give us a floating point value. And that's no problem at all because we can set this up within the ETS. Just as a small side note, sometimes you might have the case where the manufacturer adds an additional number at the beginning of the register ID. And with that additional number or prefix, the manufacturer describes the data type, so the Modbus data type of it. What I mean with that? Well, let us take a look at this example here. Now you see the exact same device, but now in this manual we see that the register starts with 32,500. Now here in this case, the manufacturer describes with the number 3 that this is the data type discrete input. Now if you would have the register 42,500, this might be holding registers. If it starts with 12,500, so with the number 1, it could be discrete input, etc. And so therefore when you later on enter this data point in the parameterization of the gateway, you have to remember that you have to delete this prefix. So the real address is 2500 and this prefix is just to document the data type. And so therefore again it's important to take a close look at the manual. So first of all, these settings here are already correct. This is the default settings of my slave device here. Then the slave address is 1. Now here in this case we don't have holding registers that we want to read, but instead we have input registers like we saw in the manual. And now here it gets important when we take a look at the type, because here we can now specify how many registers does this data point consist of. So either a word register, meaning exactly 2 bytes, so 1 Modbus register. Double word means 4 bytes, so 2 Modbus registers. And then we also have 4 word registers, meaning that in this case we have 4 Modbus registers. Now as you saw here, the data point consisted of 2 registers, therefore we have a double word register. Now I need to specify the word order. This is also something that's been specified within the manual. I leave it to default here as this fits to my device here. And then down below here I can specify the exact data type. And as you saw in my case, it's a floating point value, so therefore I use this value here. Then we can specify most or least significant bit first, again something that's within the manual. And here we can see the Modbus request in hexadecimal. That's sometimes handy to compare it against some examples within the manual. And with that being set up, I can click here on Send Modbus Request. And with that you can see we get the Modbus response, and down below here we get all the information, so the function code that was used, the address, and also the decoded value, so 231.4 volts. So that looks absolutely fine, and therefore I can use this settings now when I set up the data points. So with that you can easily check the connection to your Modbus slave. Now let us take a look into data points. Here you can see we have the data points separated in blocks by 10. So we have data points 1 to 10, 11 to 20, etc. And each of these blocks is associated to one Modbus slave. So either the slave address that we specified here as the common slave address, or a specific slave address that we can specify just for this block. Now in this case I stick to the default settings and I can give this a name. So for example, energy meter values. And then we can start to specify the data points. So the first thing that we need to do is that we need to specify the data point that we want in KNX. So no matter whether the value itself has 4 bytes or 2 bytes in Modbus, you can change it directly here with this setting. So here you specify what you need within KNX. So for example, if you have a push button with a display, you should first of all check which data point the display supports, and then you would set up this value here. So now in my case I will stick to 4 bytes and therefore I use DPT14. Then we can give it a description. So first of all, voltage L1 or phase 1 to neutral. The direction is Modbus to KNX. Then we can specify how often the value should be sent to KNX. So on change, cyclically, both or only when a read request is sent. I'll stick to on change and I'll change the value here to point, let's say 02. Then we have to specify the type. Now here in my case we had a double word register as we already saw. These are the settings that we already set up within the test environment. So I have a float value. Then you can specify a scaling factor. Now here in this case I don't need it as we saw in the test environment, but sometimes you need, for example, to divide the value by 10 or by 100 to get the correct value, and this is what you can set up here. Then the function code is read input register, and then we can specify the address 2500. Now here down below, the button actual register value will only work after you downloaded everything onto the device, because with that you can read the current value of the register. And with that I have specified my data point. As you can see here in group objects, we get this first data point that I can now connect to a group address. But before I download everything, I will quickly add some additional data points so that we can see the values then in the diagnostics. So I have now added some additional data points and already connected it to my group addresses, and as you can see here symbolized with this shield symbol, those are all secure group addresses. So what we should see now is if I go into the diagnostics and if I filter for the group addresses and start it, that we will see the group addresses or the values from our Modbus gateway. So here in this case the voltage on phase 1. So as you can see, I should turn up the on change value here. Let me quickly do that. So value change here on, let's say, 1 volt. So now the value should be sent a little bit less frequent, and as you can see here, the values were after the restart of the Modbus device also sent onto the KNX bus. Now here in this case I don't have a load connected to it and also didn't connect L2 and L3, therefore we don't see any values here, but the rest of it works fine. Now another feature that is pretty useful, especially if you are working with devices that you use commonly, so more than only once, then Weinzierl also provides you with a DCA application that you can see here. You can either download this application on the My KNX store or directly from the Weinzierl webpage, and then you simply have to install it via the settings and ETS apps. And here you can see I have already installed it, so therefore I won't add it now. And what this DCA allows us is to use templates. And you can either create templates on your own, or you can also download templates from the Weinzierl webpage. So if I scroll a little bit further here on the page of the Modbus gateway, you can see all the examples or all the templates that are already available that you can simply download as a zip file, and then you need to unzip it, and inside of it there is a file that you then need to import. So I already downloaded the template, and therefore I can click here on load from file. Here for example this device. So this here is the content of the file, that is simply a JSON file, so you can edit it also with your system editor, and then you simply need to click on import data to ETS, and with that you have an easy option to set up the different data points. And you can also do it the other way around. So if I now want to use this setting as a template, I can click here on DCA, export data from ETS, And so here you can see energy meter values, voltage L3 to N, so all the settings that I just added here, and I can save it to a file to later on use it, etc. So that's a pretty handy feature. Now one thing that I still want to show you is how you can add a second device, because until now we only used one device, the common slave address that we set up within the Modbus settings here. Now if I want to use a second device, I need to use a new data point block here, so for example 11 to 20, and then I can specify a specific slave address just for this block. So here in this case, let's say slave 2, and now here I have a one-phase energy meter. And that's basically all you need to do. So I also copy it to the description here, and then I can simply start to create the data points, which I will quickly do. So with that being downloaded, you can see I have integrated the one-phase meter here, at least with the voltage, current, power and energy counter, and with some additional group addresses. And what you can also see is that with the second Modbus slave, we also get a new diagnostic object here for this new Modbus slave device. And as you can see now, we also get the values of the one-phase meter within the diagnostics, so that just works fine. And one last feature that the gateway offers us is the DPT converter. With the DPT converter, we can convert different data point types within KNX. So what we already saw is that we can convert, for example, a 4-byte Modbus data point into a 2-byte KNX data point. But here you also have some additional options to, for example, convert a DPT, let's say, 4-byte value, so the float value. And here you could, for example, also directly convert it into a 1-bit value, where you simply need to specify the threshold. And here you see all the other options that you have. So for example, you could also convert it into a 2-byte value from here. And then within the group objects, we have two new group objects, one for the input and one for the output. And that's basically how you can set up the Weinzierl KNX Modbus RTU Gateway 886.1 secure.